Hello everyone, welcome back to sisyaclass. I hope all of you are doing great and excited for today's class. So today we are going to have an amazingly animated, you can say gamified session in which we are going to build different atoms. Yes, so I hope you are ready for an amazing session in which we are going to build different atoms with the help of simulations. Yeah. So, but before we learn how to make these atoms using simulations, we need to learn certain basic concepts, isn't it? So, I hope you are ready for the class and let's get started. So, before we start the session, today's topic, as you can see, it's building an atom. Yeah. Before we start the class, I want to give a small introduction about myself. So my name is Rutika and I did my masters from IIT Palakkad, and I hope all of you are ready to learn with me today. So basically we are going to learn about how to build an atom, isn't it? So the first question comes to us, what we have always learned in our school, that to start learning about atoms, we need to first know what is matter, isn't it? So what is matter? Matter is, like, the basic definition is, matter is anything and everything around us which occupies space and has mass, isn't it? We all know this from very lower grades, that everything around us, we ourselves are matter. The air we breathe, the food we eat, all the things, the camera, the laptop, this whole smart board, yeah, mobile phones, our clothes, we ourselves, everything is matter. Yeah, we know that. Anything that occupies space and has mass is matter, isn't it? Yeah. So I hope this basics is clear to you. Let's move on. Now, what are the building blocks of a matter? Basically everything. So the building blocks of matter, and in other words, everything around us, is nothing but the atoms, isn't it? Atoms are the building blocks of all the matter. In fact, we ourselves, all the things, the air, the food, the plants, animals, everything, the building block. Basically, you can take an example like building blocks. Yeah, let's take the example of a building. Yeah, so the whole building is made up of bricks. Yeah, we all know that any building is made up of bricks. Yes, so the singular bricks, all the bricks, singular bricks, we can consider them as the building block, isn't it? So one brick is, let's say, a building block of that whole building. So like that, the atoms are the building blocks of matter. I hope this much is clear. Let's say, look at this image. Well, let's say we are zooming into any matter. Let's say this is a solid structure. Let's say we have this pen. Let's say we have this pen. Yeah, and I zoom it in. Okay, I am zooming into this pen to find out that it is made up of tiny atoms. So all the matter, these are very compact atoms. So this is obviously a solid structure, and these are what? These are atoms. I hope this is clear to you. All these, sorry, one second. All these are what? These are atoms. Yes, I hope this is clear to you. Now let's move on. Now for certain grades we had learned that the atom is the smallest particle. Yeah, we have learned it, but then we eventually in grade 9, in grade 10, we understood that there are certain entities even inside the atom. Yes, there are certain entities, certain, particles inside the atom as well. So the atom, like according what we were taught, now evolves, and we now know that atom is no longer the smallest particle, and there are particles even smaller than the atom present inside the atom. So by the name itself, we know that what they can be called, they can be called subatomic particles. Why subatomic particles? Because these particles are present inside the atom. I hope this is clear to you. Yeah, so see this whole atom structure. Yeah, we were initially taught that this is the smallest particle. Then we realized that there are particles inside, inside of this atom. You can see all the subatomic particles, and we are going to discuss these subatomic particles like in more clarity in the upcoming slides. Okay. Yes, let's move on. Now, we will be learning about 3 subatomic particles of an atom. So, an atom comprises of an electron, a proton and a neutron. Okay. So, let's move on. 3 new words, electron, proton and neutron. These 3 subatomic particles are present inside an atom. I hope this much is clear. Yeah. Yes, so what is basically the structure of an atom? We understood, okay, atoms are the building blocks of matter. Yes, and atoms are no longer the smallest particle. There are 3 subatomic particles present inside an atom. But how do they exist? How are they present? How are they distributed inside an atom? So, now we are going to talk about the structure of an atom. So, in the structure of an atom, the atom, see, this is an atom. This is the structure of an atom, and in the atom there is a central nucleus. This is very small. This is a very small and central nucleus. Yes, as you can see, an atom has a small and central nucleus, and most of the mass of the atom lies in this nucleus. Yes, most of the, like apart from this nucleus, the atom is mostly, empty, you can say. It is majorly empty. The majority of the mass of the atom lies only and only in this nucleus, in a small, central part there in the nucleus. Yeah, the nucleus contains of the 2 subatomic particles, that is the protons and the neutrons. Yes, inside the nucleus, as you can see in this image, there are 2, you can see the green entities and you can see the blue ones. So, there are 2 entities, 2 subatomic particles inside the nucleus, that is protons and neutrons. Don't worry, we are going to discuss more about these in the upcoming slides. Yeah, 2 subatomic particles present inside the nucleus. Yes, let's move on. Now, what about the third and the last subatomic particle, that is the electron? So, the electron is not present inside the nucleus. Instead, it is present in orbits. You can say these spherical orbits. This is a 2D diagram for our better understanding, but like as you know, our world is a 3D world and things exist in 3D. So, it does not exist exactly like circular orbits, but in reality the orbits are spherical. I hope you understand the difference between a circle and a sphere. So, in reality they are spherical orbits. Yeah, not these circular in 2D, but in 3D they are spheres. Yeah. So, what are these? You can call these as they are called shells, or you can call them orbits. There are spherical shells or orbits around the nucleus. This is our central nucleus with protons and neutrons, and around that are different spherical orbits are present, in which the electrons are present. They are always revolving, rotating in these orbits, and there are certain levels of these orbits or shells, you can say. Yeah, there are specific levels like 1, 2. We'll learn more about this. Yeah, so the electrons are present in the orbits circling the nucleus. I hope you are clear with where the proton is present, protons are present, neutrons are present, and now the electrons are present. Yes, let's move on. Now, we'll learn in detail all the 3 subatomic particles. Yeah, we briefly discussed where they are present. Now, we'll learn more about the subatomic particles. So, the first subatomic particle is present in the orbits. Yeah, in the orbits, that is the electron. Electrons are the negatively charged. Yes, so the atoms have positively charged entities and negatively charged entities, also neutral entities, subatomic particles basically. So, the electrons are the negatively charged subatomic particles inside the atom. Yes, you can see these pink electrons, they are negatively charged subatomic particle. Negatively charged means they carry a negative charge, simple as that. Yes, and they are present in the orbits. I hope the image is clear to you. This is the first subatomic particle. Then second is the protons. Now the protons are positively charged subatomic particles present inside the nucleus. See, you can see these green protons, they are present inside the nucleus of the atom. How you can remember? If you think, oh, how I'll remember, like, you know, negatively charged electron, positively charged proton, what if I get confused between the two? So there's a simple trick. P for proton, yeah, and P for positive. P for proton and P for positive. Two. So you can remember it this way. P for proton, P for positive. So proton is a positively charged subatomic particle. I hope this much is clear to you. Now the third and the last subatomic particle, as the name suggests, it is neutron. Okay, the neutrons are subatomic particles with no charge. They are neutral, that's why the name is neutron. I hope it is easy to remember, and for like neutron and neutral, it is very easy. So it is a subatomic particle with no charge. With no charge present inside the nucleus of the atom. I hope this much is clear to you. Yeah, you can see the diagram. Electrons are there inside the nucleus, the protons are there and neutrons are there. Now you might think, this question might arise in your mind, like, okay, we understand. Now you can count the number of protons. Okay, you can count, let's say 1, 2, 3, 4, 5, 6. Yeah, how many protons are there? And yes, I can we can write this way as well. An electron is represented by E minus. If I want to write an electron, I can write a shortcut like this, E with a minus sign, because E for electron and negative sign because it is negatively charged. How I'll write a proton? Very simple, you can guess it. I'll write a small p with a positive sign on its head. Yeah, p plus. And how I'll write a neutron? Very simple, small n. Okay, because it does not carry any charge. Now an atom, we know that an atom is electrically neutral, means it does not have any charge on it. So like, just think about it, do the math. What is going to happen? The positives and the negatives are going to cancel each other. They are going to cancel each other's effect. Don't you think? Let's count the number of protons. See, 1, 2, 3, 4, 5, 6. Okay, so 6 protons are there. Yeah, let's count the number of electrons. 1, 2, 3, 4, 5, 6. How many electrons? 6 electrons. Now you do the math. Plus 6 minus 6 is equal to 0. Isn't it? Is equal to 0. That means our atom is electrically neutral. Yes. So now you might think that we have plus and minus, positive and negative. So what is the need for neutrons? Yeah, you have positive charges, you have negative charges. Now you might think, why do we need the neutral charges? Yes, so just think about it in this way. You can see in the nucleus, I told you it's a small portion of the, like very small central part of the atom, and so many protons are present in it. Look at it, so many protons, so many positive charges are accumulated in that nucleus. Think about it. What do you think about like charges? What do you think about like charges? We know something about like charges, about opposite charges. Yeah, what is it? So don't you think that we know this, that like charges repel? Like charges repel each other. Don't we know that? Like charges repel each other. Now imagine these like large number of positive protons together in such a small nucleus. What would happen? What would happen? Won't the repulsion be huge? Won't the repulsion be huge? Yeah, like they would just repel each other. They would, want to move away from each other. And do you think that would be great for the stability of an atom? What do you think? What stability of the nucleus indeed, and because of the nucleus for the atom. Yeah, do you think that the positive protons are going to stay together? They would definitely want to move away from each other, which will lead to the instability of the nucleus, hence the instability of the atom. Yeah, yes, you agree with me? So to nullify, you can say, to the balance out this repulsion, yeah, to make the nucleus, the atom, more stable, we have neutrons. Yes, neutrons occupy the space along with the protons. Yes, and they kind of stabilize the nucleus. They reduce the proton repulsion, and they stabilize the nucleus, hence they stabilize the atom. I hope this is clear to you why neutrons are important. Even though they don't carry a charge, they don't affect the atom in any way, but why they are important for the stability of the atom. Yes, I hope this much is clear. Let's move on. Yeah, and now these atoms, we talked about that everything around us is matter. It is made up of atoms. Yeah, but not everything is made up of the same atoms, right? Not everything is the same. Do you think that I am made up of the same atoms, same as this pen or this smartboard? No, right? Of course, I don't think that we are entirely same, like our human body is entirely same as the smartboard. Yeah, so the atoms are different, the matter is different. So how can you quantify, or how can you know what all matter can exist? So in chemistry, not in chemistry, in general, there are 118 elements. That means there are 118 elements. Let's say hydrogen, carbon, nitrogen, sulfur, oxygen, yeah, helium, neon, a lot of elements. So total 118 natural plus man-made elements exist. That's how we know that 118 atoms are there, types of atoms are there. So everything around us can be made up of, like, a lot of atoms are very common, but some atoms elements are very rare. So but in total 118 elements are there. Yes, and how you'll know which 118? So this is the periodic table, and all the 118 elements are present here. See, 118 elements are there. So it's like, don't worry, don't get panicked by looking at this huge periodic table. I'm not asking you to by heart this whole thing. Just for a reference, I have shown that there are 118 elements, and therefore 118 types of atoms exist. Yeah, let's move on. Now, we studied about the number of protons, number of electrons, number of neutrons. Now, if I want to, I hope you saw this table and you understood that what this table shows. This table shows that you have 118 elements, and it shows the symbol allotted to all the elements. See, hydrogen is given by H+, like in the previous slide as well. H+, H. The hydrogen is H. Carbon is C, nitrogen is N. So certain symbols are allotted to all the 118 elements. Yes, you can see helium, lithium, beryllium, all the chemical symbols are allotted to all the elements. Yes. Now, to add more information to the chemical symbol, we have two properties, quantities, you can say, that we need to mention about a element. So the first is atomic number. We need to write, when we are talking or learning about chemistry, we need to know the atomic number and the mass number of an element. Yes, so what is atomic number? Atomic number is denoted by Z. It is nothing but the number of protons. Yes, but number of protons in an element, in an atom. Yeah, in an atom. Yeah, and number of, we are always talking about a neutral atom. We are always talking about a neutral atom. So in neutral atom, the number of protons are equal to the number of electrons as well. Number of electrons as well. But by definition, it is atomic number denoted by Z is nothing but the number of protons. I hope this much is clear to you. And I said that there are going to be two quantities which are important in when we are talking about elements, atoms and everything. That is, first is atomic number and second is mass number. And I want you to pay attention to one more thing. In this periodic table, the elements are arranged in the increasing order of their atomic number. Let's say, hydrogen's atomic number is 1. So after hydrogen, atomic number 2, helium, then lithium 3, beryllium 4, boron 5, carbon 6 and so on. So this periodic table is arranged in the order of increasing atomic number of elements. I hope this is clear. Yeah. Now we talked about atomic number. The second quantity is mass number A. Mass number is denoted by A. Now mass number is, first of all, I hope you remember that the protons are present in the nucleus. So we are basically, the numbers, all these figures are revolving around what is present inside the nucleus, because that amount is not going to change under any circumstance. It is a very reliable count. Okay, so we rely on whatever is present inside the nucleus. So atomic number is number of protons. It is never going to change for an atom or element. And the second is number of mass number, that is denoted by A. So A is number of protons plus number of neutrons. These two together are protons and neutrons together are also called nucleons. Yes, why they are called nucleons? Because both of these entities are present inside the nucleus. Yes, very simple. Protons and neutrons together are called nucleons. So mass number is nothing but the number of nucleons. Yes, mass number is nothing but the number of nucleons. Protons plus neutrons, that is nucleons, present inside the nucleus. So let's say, like this is the representation, then this is how you will represent an element at all times. Okay, you will write the symbol of the element like hydrogen, carbon, nitrogen, oxygen, sulfur, whatever the symbol of the element is, symbol of the element. Yeah, and on the top you will write the mass number. What is the mass number? Number of protons plus neutrons or else nucleons, and in the bottom you will write the atomic number. Yes, you will write the atomic number, that is Z. Let's move on. This is an example. Let's say we have oxygen. Oxygen symbol is O, and this is the mass number. This is A, and this is the atomic number, that is Z. Atomic number of oxygen is 8 and the mass number is 16. Can you tell me atomic number is what? Number of protons. Yes, number of protons is 8. Now can you tell me how many neutrons are present in an oxygen atom? What do you think? Do the math. What do you think? This is the number of protons and this is number of protons plus neutrons. So the number of neutrons will be 16 minus 8, that is 8. Yes, do you agree with me? Yeah. Let's move on. So now the topic is shells of an atom. We talked about all the entities and how the structure and everything is. Now we need to name and understand the shells or the orbits in which the electrons exist. Yeah. So the shells of an atom, there are, like, we go on like 1, 2, 3, 4, we keep on counting like that, and certain names are given to this shell. So the first shell is K shell, the second is L, M, N and so on. First, second, third, fourth, the naming is given like that. Okay, starting from K. Yes. Okay, and there's certain rule. One second. There's certain rule which we need to follow. Like, look at this shell. The first shell is so small. Do you think it can accommodate infinite number of electrons? No, right? It is not possible. So there are certain, there's a formula which tells us how many electrons can be occupied in one shell. Okay, so that formula is 2n square. It is a very important formula. Each shell can occupy only 2n square electron. And what is n? The number of the shell, whether it is first shell, it is second shell, third or fourth, like that. Yes. So in the first shell, if you put the formula 2n square, n is equal to 1, so it will be 2. So the first shell can accommodate only 2 electrons. Yes, and thus in the second shell you put n is equal to 2, so it will come as 8. Yeah, so this is how you can find out how many electrons can be accommodated in the shell, K shell, L shell, like that. Moving on. Yes. Now finally we are going to understand how the simulations, or how we can build an atom using simulations. Yes. One second. Yeah. So we have the simulations here, and we'll one by one build a few elements. Yes. So let's start with our first element, that is hydrogen. For hydrogen, you will tell me the atomic number is 1. So that means that the number of protons will be 1, isn't it? Yes. And the number of protons will be 1. So the number of electrons will also be 1, because our atom is always neutral. We are always making a neutral atom. Yes. And I want you to see here in this whole simulations, we will be able to see the charge on the atom that we are making, the mass number of our atom. Yes. And we have of course the periodic table here, and we will see the element, whether it is, we are building a neutral atom, we are not focusing on ions here, and whether our atom is stable or unstable. Okay, how it will be unstable, we will see that. Now we know our hydrogen atom. One second. Yeah, our hydrogen atom has 1 proton, and there is one specialty about this hydrogen atom, that it does not have a neutron. Yes, look at this. It is a stable atom without a neutron. So how I will write hydrogen atom? I will write it like this. The atomic number is 1 and the mass number is also 1. Yes, you can see the mass number is also 1 because it does not have a neutron. Now let's say there are 3 isotopes of hydrogen. Let's say I am adding one neutron. One second. Yes, I am adding 1 neutron. Now the mass number becomes 2. Yes, the mass number becomes 2, isn't it? Now how will I write it? H. Yes, atomic number is still 1 because atomic number is the number of protons, but the mass number has changed to 2 and it is still stable. Yes, you see that this is an isotope of hydrogen which is still stable with 1 proton and 1 neutron. Now let's see what happens if we add one more neutron. We are adding one more neutron. Can you see? Are you able to see what is happening? So the atom is not stable anymore. Yeah, because usually what happens, I'll tell you. We have 1 proton to balance out the repulsions or to manage, to increase the stability of the atom. For 1 proton, usually, okay, not always, but usually there is 1 neutron. 1 proton, 1 neutron, 1:1 ratio of protons and neutrons are present. But sometimes when that ratio becomes, the number of neutrons becomes way more or way less than the number of protons, the nucleus becomes unstable. Yeah, it becomes unstable and you can say it becomes radioactive. So this is a radioactive isotope of hydrogen. You can tell me now, what is the atomic number and mass number? What is the atomic number and mass number? So if I write hydrogen, the atomic number cannot change for an element. It is always the same. It is 1. Yeah, and look at the mass number. See the mass number. It is 3 because 1 proton and 2 neutron, it becomes 3, and this is unstable isotope, unstable atom of hydrogen, isn't it? Yeah. So let's try making another atom. Say I'll remove these neutrons for you. Yeah, this is hydrogen. Let's make the second atom, like second element, that is helium. So helium has 2 protons because that is the number of protons needed in a helium atom, and 2 protons, that means 2 electrons. Yeah, yes, see, you can make 2 electrons, then you have to add protons. Let's say 2. Now you can guess how many neutrons are needed. Yes, is stable, and we were considering a 1:1 ratio, so this becomes a stable helium atom. Yeah, it is neutral, isn't it? Now see, I told you the rule of 2n square. So the first shell can only accommodate 2 electrons. Let's see about the next element, that is lithium. Now this shell is fully occupied. Let's try for the next element. Yeah, we have 3 protons now. We have 3 protons, and now let's see whether we can put this electron into this shell. Let's try. Let's try. I am trying to put this in the first shell, but it is not accommodating it. That means this first shell is fully filled and it can accommodate only 2 electrons. Now the next electron goes in the second shell. Yeah, very obvious, it goes in the second shell. And now the nucleus is unstable because look at the ratio of protons and neutrons. Let me add. So now the atom is stable. The lithium atom is stable. Now we learned from hydrogen, helium, lithium. We learned about 3 types of atom of hydrogen, 3 isotopes of hydrogen. Let's try one last one for neon. Okay, you can try these simulations by yourself, or we are going to take a lot of more lectures based on these simulations for different concepts. So I hope you will stay tuned with us. Let's try one last one for neon. Yes, so neon, the atomic number is 10. Yes, so number of protons are going to be 10. Yeah, a huge atom. Let me add all the 10 protons, and now you will see that I am going to add. I hope you remember the 2n square rule, that in the second shell the maximum number of atoms will be 8. So you count, these are 2, then 3, 4, 5, 6, 7 and 8. Of course, the nucleus is not stable because you see the ratio. See, look at the mass number. Atomic number is 10. So 10 minus 4, 10 protons and only 4 neutrons. Will it be stable? No. We just need 1:1 ratio. We need to, kind of separate the protons to reduce the repulsion. So we'll add 10:10. So for 10 protons, we'll add 10 neutrons. This is not always the case, but in a lot of cases this works. Yeah. Yes. Now look at this. For 1:1 ratio, 10 protons, 10 neutrons, mass number becomes 20, and our new neon atom is stable now. I hope you are able to understand that this atomic number of neon is 10, number of protons are 10, neutral atom, that's why number of electrons are also 10, and the number of neutrons are also 10. So the mass number becomes 20. I hope you learned something new today with this interesting simulations, and if you have already learned this was kind of a recap, a refreshing recap for your whatever you have learned till now, and I hope this was interesting for you. So we are going to bring a lot of this stimulation classes in the upcoming sessions of YouTube. So you guys stay tuned with us, download our app. Yes, I hope you will download our app from Play Store. Yeah, and you can subscribe to our channel, you can follow us, so that we are encouraged to make more such amazing content, and you will stay tuned with us. Yes, so thank you so much for joining for this session, and I hope to